Hi, so welcome to the fifth lesson. Today's lesson is about related rates, and it's sort of an extension from what we did before regarding derivatives. So let's get started. First, what is related rates, right? Many variables have a familiar relationship, or in other words, a way variables are related to each other. A great example is the Pythagorean theorem, as variables are related to each other to find the existence of another variable. Let's say a triangle's dimensions are changing. This means that a dimension, A, B, or C, has a rate of change, and this rate is related to another dimension's rate of change. So basically, you find it by differentiating your relationship with respect to one specific variable. This is similar to implicit differentiation. Usually it is with respect to time, but it's not always with respect to time. So to look at what this actually means, let's examine an example. If y squared equals 3x to the power 4 plus 6x, find dy dx when x equals 1 and dx dt is 2. So first we differentiate implicitly. So 2y, so 2y dy dt equals 12 3 dx dt plus 6 dx over dt. So what you can notice here is that unlike implicit differentiation, I differentiated all of the variables. Now we input the values that we know. We have to look at this equation, right? So we know the value of x when it's 1. And we know that y squared equals 3x to the power 4 plus 6x. So y squared, in other words, is also equal to 1 plus 1, which is 9. In other words, y is 3. Now, then we plug the values in. So 2, 3 dy dt equals 12 times 2 plus 6 times 2. And if we calculate this, this becomes 6 dy dt is 36, which leads to the answer that dy dt is 6. So that's how you solve. Now, here are some guidelines to solving related rate problems. First, you draw a picture. Usually, if it's not a question regarding like an equation like this, if it's like a square, a rectangle, a triangle, or a different shape, it's much easier for you to draw a picture and then solve. Second, make a list of all known and unknown rates and quantities. Third, relate the variables in an equation. So basically, it means just write an equation. Fourth, differentiate with respect to time. Fifth, substitute the known quantities and rates and solve. What's important is you substitute a non-constant quantity before differentiating is not allowed. So basically, this means that before you differentiate, if you just plug this in, it's not allowed. So now we have quite a few example questions that we should take a look at. And, and these look at like a lot of different types. So I think it will make it much easier. So let's look. First, the width of the rectangle is increasing at a rate of 2 centimeters per second, and its length is increasing at a rate of 3 centimeters per second. At what rate is the area of the rectangle increasing when its width is 4 centimeters and its length is 5 centimeters? So if we draw what's happening here, this is the width and this is the length. And if we look at the equation, and if we look at the problem, dw over dt is 2 because the width of the rectangle is increasing at a rate of 2 centimeters per second. And if we see, the length is increasing at 3 centimeters per second, which makes it so dl dt is 3. And we have to find the rate that the area of the rectangle is increasing. Basically, which means that we have to find dA dt. And we also know the values that the width is 4 and the length is 5. So using this, we're going to form an equation and we're going to solve. So the area of the rectangle is A equals L times W, right? So we differentiate equals dl dt times W plus L times dw over dt. And we basically substitute all of the values that were over here, which becomes 3 times 4 plus 5 times 2, which becomes 22. So the answer is that it's increasing at 22 centimeters squared per second. And make sure you get the units right. So that's how you solve related equations. Now the following ones look at more complicated ones. So let's look. Assuming that you read the question, we first organize all of the variables, right? So y. Let's first draw what's occurring here. Basically, what's occurring is that there is a police car at here. There is a speeding car here. And then we're going to place the variables so that this is y, this is x, and this is z. Okay. So let's take a look. We know that y is 0.6. We also know that x is 0.8. We know that dz over dt is 20. And we also know that dy over dt equals negative 60. So we look at the equation, and basically we have to look at the Pythagorean theorem. So x squared plus y squared equals z squared. If we differentiate, right? And we also need to find the value of z. So, and z is quite easy because we have the values of 0.6 and 0.8. So we just have to use the Pythagorean theorem. 0.8 squared plus 0.6 squared is z squared. And if we solve, z is 1. Right, so you plug those values in. 2 times 0.8 dx dt plus 2, 0.6, negative 60 equals 2, 120. So 1.6 dx dt minus 72 is 40. This brings the answer. That dx dt is 70 miles per hour. So it's actually really simple once you get the hang of it, because you just have to write the equation correctly, and then solving it is really easy. So we're going to look at the next question. This one is really much easier because it's just looking at an ice cube. So let's draw what's happening. Basically, this means that there's a cube. And all of these, they're all S because they're all cubes, right? So we know that the ice cube is melting at a rate of 5 cubic centimeters per hour, which means that the volume is decreasing at negative 5. We have to find ds dt, and we know that side is 3. So volume is side cubed, so we differentiate. And then we plug the known values in. Let's see, which yields the answer equals negative 5 over 27 centimeters per hour. So that's the answer. The next one is about a circular pool of water. Basically, the next one is about a circular pool of water. So let's take a look, right? We draw the circular pool of water. And this is the radius, obviously. So we know that dA dt is 16 pi. And we have to find dr dt. And we know that r is 4. All right. So we write the equation. A is pi r squared. dA dt is 2 pi r dr dt. 16 pi is 2 pi times 4 dr dt, which yields the answer. Dr dt is 2 inches per second. Next one is basically a sphere. And because we already know the variables of the sphere, let's just go ahead. So dv dt is 60 pi. We have to find the area this time. So du dt and r is 4. Now, we know that a is 4 pi r squared. So we differentiate, equals 8 pi r dr dt. Now, we don't know the value of dr dt, which is a problem because we need to find dA dt. So how can we find it? Basically, we know that the volume dV dt is 4 pi r squared dr dt, right? Which 60 pi is 4 pi 4 squared dr dt. So we can find the value of dr dt through this, which is 15 over 16. So now we can plug this in here. So dA dt is 8 pi times 4 times 15 over 16. So the answer becomes 30 pi inch squared per second. And you can calculate the exact values by calculating pi, or you can just leave it at here. So now let's look at the next question. Basically, he's using a ladder to paint the house, right? And it might be sort of hard to understand, so I'll draw a diagram to make it easier. Basically, it looks like this, with this being the ladder and this being the house. Let's make it more like a house. Okay. So we put, this is Z, this is Y, and this is X. And what's interesting about this is it says it's a ladder, right? Which means the value of Z cannot change because it's a ladder, right? You can't really change the length of a ladder. So Z will stay at 17. dx dt is 3. We have to find dy dt, and y is 8. So first, to find the value of x2, we just use this. So x is 15. Now we use the Pythagorean theorem. And like I said, z is a constant, so we just do this. And if we differentiate it, 2, 15, 3 plus 2, 8, dy dt equals 0. And this yields the answer that dy dt is negative 45 over 8 feet per second. Now, this question may have been hard to understand at first, but once you draw a diagram and you fully understand, it's really easy to just write an equation and answer. So look at the last one. Basically, this is a similar thing that it's sort of hard to understand, but I'll draw a diagram. Basically, what this is saying is that there's like that, a triangle, and then the boat is here, basically. Say that this is the boat, basically, and then that's y, that's x, that's r, and then this is the water. And y is a constant because it's just how high the boat is. So y is 7. dr dt is -4. We have to find dx dt. And r is 25. We used the Pythagorean theorem. So x is 24. Now x squared plus 7 squared equals r squared because y is a constant. And if we differentiate it, right, and this yields the answer So that's how you would find related rates for all of these following questions. And these are all very like diverse type of questions, right? They all look at different types of shapes and different equations. So I feel like this would be a useful practice for you. If you're feeling confused, just go over these questions once again, try to solve them by yourself, and that would help you a lot to prepare for any related rates questions. And that's it for today's class. Thank you for listening, and see you in the next class.